The previous video we had learned about the various methods of preparation of alkanes. In this video we are going to be talking about physical properties of alkanes. Let's start with the nature. Now our hydrocarbons, or alkanes rather, alkanes consist of CC and a CH bond. Now the electronegativity of carbon is 2.55, whereas the electronegativity of hydrogen atom is 2.2. So their electronegativities are quite close. This means neither of them want to pull the electron towards them. So if there was an oxygen atom, I could tell you, okay, listen, the oxygen is going to pull the electrons towards it, and that will lead to a difference in electronegativity. But because their electronegativities are quite close together, this leads to these compounds, alkanes, being non-polar. So alkanes are non-polar in nature because of the less difference in electronegativity of Cc and between C and H. That's the first thing. Second thing is, if you remember, you would have learned about the various kinds of forces that hold together molecules. Okay, one of them is called as van der Waals forces. So here the molecules are going to be held together by van der Waals forces. This is very important. Okay, so molecules are held together by van der Waals forces, and which these forces in turn depend upon the size and structure of the molecule. So van der Waals forces are the ones responsible for these molecules to be held together. These molecules are also non-polar in nature due to the less difference in electronegativity between carbon and hydrogen atom. The third thing that I want to talk about when we talk about nature is that compounds, alkanes having C1 to C4 are gases due to weak forces of interactions, whereas C5 to C17 they are liquids. More than 18 atoms, these alkanes become solids. So let's talk about boiling points. That is why we have this paper over here with the table. Now here, if you see, I have the boiling point of, this is the same table you have in your textbook. Okay, notice we have written, now let's look at the boiling points. Okay, as we go down the table, we know that the molecular mass is increasing, and as we go down the table, there is an increase in boiling point. The reason there is an increase is because as the structure, the size increases, then there is an increase in the boiling point, and there is between two consecutive homologues, that is when there is a new CH2 added, then the boiling point is increasing by 20 to 30 Kelvin. And that is why the reason there is an increase is because, again, when we talked about the nature, they are held together by van der Waals forces. Van der Waals forces again depends upon the structure, or rather the size also. So because the van der Waals forces depends upon the size of the molecule, as the size increases, there is an increase in the van der Waals forces, and because of that, the boiling point is increasing. Quite easy, right? But here in between, we have cases where we're talking about isomers. If you remember, when we talked about the various isomers of alkanes, I had asked you that, we'd also talked about the fact that there was a difference in boiling points. And I asked you to think about why that is the case. That is also due to the van der Waals forces. Now, let's take the example of butane and 2-methyl propane. Okay, so I'm just going to write the carbon skeleton. I'm not filling in the hydrogen atoms. So butane is a straight chain, right? Whereas its isomer 2-methyl propane is having a branch. Now what is happening over here is, this is an open structure. You have the hydrogen atoms also coming in and they will fill in the valencies. Okay, but here it's an open structure. Whereas in case of this branched structure is actually quite compact. And the van der Waals forces will decrease when there is, when the structure becomes more compact, or the better way to put it would have been, van der Waals forces is going to increase when the structure is increasing, right? That's exactly why as we went down here, it meant that you have an increase in boiling point. So here what's happening is the molecule has basically become smaller because of the branch, and because it's small, its boiling point is less. Same goes for pentane, 2-methylbutane and 2,2-dimethyl propane. So here the boiling point is 309.1 Kelvin. For 2-methylbutane, it is 300.9 Kelvin, and 2,2-dimethyl propane is 282.5 Kelvin. Notice all of them have the same molecular mass and the same molecular formula. But here, this molecule is more compact. So in case of pentane, this is going to be pentane. And this is 2-methylbutane, and this is 2,2-dimethyl propane. Okay, I'm sorry if it's a little messy, or okay, wait 1 second. And it's obvious that this structure is more compact than this one, and that is why its boiling point is 282.5 Kelvin. On the other hand, if you notice, this is relatively more open, and so it has a higher boiling point, that is 309.9 Kelvin. And here it's an open structure, so it will have, compared to its isomers, this is going to have the highest boiling point compared to its isomers. I'm not talking in general, I'm just saying comparison with its isomers. The open chain is having a higher boiling point because there's the structure size is increasing. There is an increase in the increase in the van der Waals forces, which in turn increase the boiling point. The next is the melting point. Look at these values over here. Okay, you have, it starts with 90, okay, for methane. It seems to go up to 101 for ethane, and then it goes back down for propane, that is 85.3. So if you notice, for boiling point, we just said as we go down the series, as the molecular mass is increasing, as the number of carbon atoms is increasing, there is an increase in boiling point. But in this case, there was no particular order which is observed. But the reason they say this is because for even number of carbon containing compounds like ethane and butane, they seem to be having a higher melting point than an odd number of carbon containing compounds like propane and pentane. Now if you see, ethane is 101.0, butane is 134.6, whereas propane is 85.3 and pentane is 143.3. So there seems to be a difference in terms of the number of carbon atoms, and the odd number of carbon atoms containing alkanes seem to be having a higher melting point even number is having a higher melting point compared to the odd number. And they say that it's probably due to the symmetry, because the even number of carbon atoms. Now let's take for example your propane. Propane is 3 carbons, 1, 2 and 3. Butane is, there is more symmetry in these, and so they have, because of their higher symmetry, due to that they are more closely packed, and because of them being closely packed, they will have more van der Waals forces, and so in turn they have a higher melting point compared to their odd number counterparts. And the next one is going to be solubility. As we know, alkanes are non-polar in nature, and we also know that light dissolves light. So non-polar alkane will not dissolve in water, which is polar in nature. However, alkanes get dissolved in various non-polar solvents like ether, benzene, carbon tetrachloride, etc. And there is a decrease in solubility of the alkane with increase in the molecular mass. And when you so the petrol Petrol is one of the most commonly used fuels, and we know that, right? That's actually quite useful even in dry cleaning. So grease is non-polar in nature. Petrol being non-polar, very different. We won't use the petrol that you get in the petrol pump, but we will use a different kind of petrol, or rather a lower fraction of petrol. And what it'll do is it will be able to remove since it's non-polar, it will be able to remove the non-polar grease as well. With that, we're done with the physical properties of alkanes. We started with nature, spoke about why they are non-polar, and what are the forces that hold these molecules together. Then we moved on to boiling point, studied about the melting point and solubility, as well as, we also basically use this to compare everything. With that, we're done with the physical properties of alkanes. In the next video, we'll be talking about chemical properties of alkanes.